everyone, this is Jana Raja, Assistant Professor at IT/ICT Department of LJ Institute of Engineering and Technology. Welcome to the 7th lecture of Unit 6. In previous lecture, we have discussed about the testing strategies in which we have learned about a validation testing and a system test. So now in today's lecture, we will learn about a testing conventional application in which we will discuss about white box testing and a black box testing. So let's start with the today's topic, that is testing conventional application. So there are two general approaches for the software testing, that is white box testing and another is a black box testing. Okay, so white box testing means glass box testing is a testing technique that examines the program structure and derive test data from the program logic or code. Okay, so that means in white box testing, it is a kind of testing technique in which you are examining your program structure and you are deriving some test data from your code. Okay, so from your logic or from your code, you are deriving your test data in a white box testing. Okay, so the other name of glass box testing are clear box testing, open box testing, logic driven testing or a path driven testing, and also a structured testing. Okay, so these are the other names for a white box testing. Okay, so in white box testing you are testing for the program structure. Okay, and in a black box testing, it is a method of software testing that examines the functionality of an application based on the specification. Okay, so if you are giving some specification, then based on the given specification, how your particular software is performed. Okay, so here in black box testing, you are testing for the functionality. Okay, so you are examining the functionality of an application based on the specification. Okay, it is also known as a specification based testing. Okay, and independent testing team usually perform this type of testing during the software testing life cycle. So here independent testing team are usually using that particular black box testing for the software testing life cycle. Okay, so in black box testing, you are testing for the functionality. Okay, so this is about the white box and black box testing. Now let's understand in brief about both the approaches, that is white box and a black box. So let's start with the white box testing. So white box testing is a software testing method in which the internal structure, design and implementation of the item being tested in known to the test. Okay, so if you are testing any software, then how that particular software product is performed, means if there is a return like addition, then it will obviously perform a addition operation. Okay, so white box testing is a software testing method in which internal structure or design or implementation of item being tested, that is known to the testing team. Okay, so it is like the work of mechanic who examine the engine to see why particular car is not moving. Okay, so here mechanic is already aware of the engine system. Okay, so based on the engine or by examining the engine, that particular mechanic is able to analyze what is the problem during the car moving process. Okay, so similarly in white box testing, you are checking for the internal structure and that is already known to the testing team. Okay, so the main focus of white box testing is on ensuring that even abnormal invocation are handled gracefully. Okay, so if there are any features or function that is abnormally performed, then abnormal invocations are handled gracefully in the white box testing. Okay, and using white box testing method, you can derive test cases that guarantee that all independent within a module have been exercised at least once. Okay, so if you have given many if condition or else condition, then you are testing for the each and every condition. Okay, so here you are guaranteed that all the independent paths within that particular module have been exercised at least once, and it also exercises all logical decision on their true and false side. Means if you are defining the if condition, then you are checking for the true part as well as you are checking for the false part. Okay, and it also execute all loops at their boundaries. Okay, so if you have written any loop in your software, then it will check for the loop to completion. Okay, so till the last level, means till the boundary that particular white box testing is executing. Okay, so it execute all the loop at their boundaries. Okay, and it also exercise internal data structure to ensure their validity. Okay, so how that particular internal data structure is working and what is the validity of that particular data structure. Okay, so in white box testing you are ensuring about all these test cases. Okay, so here you have one questions like why it is called white box testing. Because here the tester required knowledge of how the software is implemented. Okay, so as we have discussed previously that this particular testing is performed when a testing team is aware for the particular software, that particular software is working in what kind of behavior. Okay, so it is called white box testing because here the tester required particular knowledge of the software, means how the particular software is implemented. Okay, that's why it is known as a white box testing. Okay, and it is applicable to the following levels of software testing, that is unit testing. In unit testing you are testing the path within the unit. Then in integration testing you can also use white box testing. So in integration testing for the path between units. Okay, so if you have defined multiple units, then you can check for the integration whether all the paths are properly working. Okay, and the system testing for the testing path between subsystem. Okay, so in unit testing you are checking for the component. In integration testing the group of components are validating. Okay, so a group of components are testing, and in a system testing the system is checking as a whole product. Okay, so white box testing is applicable to the all levels of software testing. Okay, and the main goal of the white box testing is to ensure that all statements and conditions have been executed at least once. Okay, so if you define any if condition, any while condition, or any do while condition, then all the statement and conditions have been executed at least once. Okay, so one time you have to execute all the statement and condition. Okay, so this is the main goal of white box testing. Okay, so why and when white box testing is used? So white box testing is mainly used for detecting logical errors in the program code. Okay, so if you have written a code of addition of any number and that particular code is performing subtraction or any other operation. Okay, so white box testing is used to detect some logical error in your software product. Okay, in your program code, and it is used for debugging a code, finding some random typographical error, and uncovering incorrect programming assumption. Okay, so it is also useful for debugging a code. You can also find some random typographical mistakes. Okay, and you can also uncover some incorrect programming assumption during the white box testing. Okay, and white box testing is done at the low level design and implementable code. Okay, so if you have developed any minimized code and if you have developed any low level code, then you can also use white box testing as a testing strategy. Okay, and it can be applied at all level of system development, especially unit, system, and integration testing. Okay, and white box testing can be used for other development artifacts like requirement analysis, designing, and test cases. Okay, so this is about why and when you are using white box testing. Okay, so let's understand advantages and disadvantages of white box testing. Okay, so advantages are like it reveals error in a hidden code. Okay, so if you have any code that is hidden, so by using white box testing you can easily reveal that particular error from the hidden code. Then it also spots the dead code or other issue with respect to the best programming practices. That means if there is a kind of code that is in a no longer use, okay, and or that particular code is not used in that particular software product. Then it also identifies some dead code, means it also spot the dead code or other issues with respect to the base programming practices. Okay, then another advantage is like testing can be commenced at the earlier stages. Okay, so as one need not wait for the GUI to be available. Okay, so if you have done with some coding part and the GUI part is still remaining, then also you can perform white box testing for checking the features and functionality, means how particular software is behaving. Okay, so you can also use white box testing. So that is the advantage of white box testing. Then the other advantage is like testing is more thoroughly with the possibility of covering most parts. Okay, so in white box testing you are checking for the unit, system and integration testing. Okay, and the main goal is to check all the statement and condition at least once. Okay, so here testing is more thoroughly and have some possibilities of covering all the path. Okay, so this is the also an advantage of white box testing. Now there are also disadvantages of this particular testing strategy. So disadvantages like it is expensive, as one has to spend both time and money to perform the white box testing, because if you have developed something and you are checking for the error in your software product, then it is obviously time consuming and you are wasting your money. Okay, so to perform white box testing, okay, so it is expensive as one has to spend both time and money. Then every possibility that few lines of code are missed accidentally. Okay, so there is possibility like if any lines of code are missed, then it also leads to the software failure. Okay, and in depth knowledge about the programming language is necessary to perform the white box testing, because you are revealing some hidden errors. Okay, so if you don't have any proper knowledge of programming language, then it is not possible to check for the white box testing. Okay, so in-depth knowledge about the programming language is necessary to perform the white box testing. And since the test can be very complex, high skill resources are required with thorough knowledge of programming and implementation. Okay, so for particular white box testing you need a proper skilled person. Okay, so proper knowledge of programming language. Okay, so these are the disadvantages of white box testing. Okay, so this is all about advantages and disadvantages. Now let's discuss more about white box testing. So let's discuss tools and techniques, means methods of white box testing. So a major white box testing technique is a code coverage analysis. Okay, so code coverage analysis eliminates gaps in a test case suits. Okay, so it identify areas of program that are not exercised by a set of test cases. Okay, so it identify some of the area, means some of the code that is not exercised by a set of test cases. Okay, so once gaps are identified, you create two test cases to verify untested parts of code and thereby increase the quality of the software code. Okay, so test case means if you are testing any software, then you are preparing some test cases, means you are preparing for the testes. Okay, so that means you are developing some criteria, like I have to check for the addition operation, subtraction, multiplication for the calculator software. Okay, so this is the test cases. Okay, so in white box testing you are identifying some area of code that are not exercised, and once you have analyzed that particular gap, then you can create a test case to verify untested parts of code, and by performing such things you can also increase the quality of your software product. Okay, so there are automated tools are also available to perform the code coverage analysis. Okay, so there are normally three techniques for white box testing strategy. Okay, so first is a statement coverage, then branch and decision coverage, and the path coverage. So statement coverage, this technique is aimed at exercising all programming statement with a minimal test. Okay, so by performing minimum test, you have to exercise all the programming statement. That is the main things about the statement coverage. Then branch and decision coverage means this technique is running a series of tests to ensure that all all branches are tested at least once. Okay, so if you have defined any if condition, okay, so there is any decision making statement in your software product, then you are checking for the both the statement. Okay, so here branch and decision coverage is ensuring that all the branches are tested at least once. Like some tools, for an example of tool that handles branch coverage testing for C, C++ and Java application is TSET path. Okay, so you can perform branch and decision coverage testing by using that particular tool. Okay, and the last is path coverage testing. So this testing corresponds to the all possible path, which means that each statement and branch are covered. Okay, so in path coverage you are testing for all the possible path in your software system. Okay, so let's understand each and every technique in a brief with example. So first is a statement coverage. Okay, so statement coverage in white box testing technique, which involves the execution of all the statement at least once in the source code. Okay, so through statement coverage, we can identify the statements executed and where the particular code is not executed because of blockage. Okay, so you can also identify is there any blockage in your software product. Okay, so if you have developed any code and that particular code is not performing properly, then you can also analyze or you can also identify the blockage in your software code. Okay, so using this technique, we can check what the source code is expected to do and what it should not. Okay, so what particular requirement that is you are performing, okay, and what particular requirements are not performed. Okay, so in this technique, we are checking for what the source code is expected to do and what it should not. Okay, and it also used to check the quality of the code. Okay, and the flow of different paths in the program. Okay, so if there are any path, then it also identify using the statement coverage. Okay, so the statement coverage covers only the true condition. So the main drawback of this particular technique is that we cannot test for the false condition. Okay, so if you have defined any if condition, then it in statement coverage it only check for the true condition. Okay, so it always ignore the false condition. Okay, so in statement coverage it only cover the true condition, and the statement coverage is count as per the given formula, that is statement coverage equal to number of statement executed divided by the total number of statement in your code multiply by 100. Okay, so if you want to calculate the statement coverage, then you can calculate by defining the number of executable statement. Means if there is a if condition, then only consider the true value. Okay, so the number of executed statement and then divide by the total number of statement in your source code. Okay, so if your source code have a 10 lines, okay, so you are dividing that particular executed code by the 10 and perform multiplication of 100. Okay, so this is the formula of statement coverage. Now let's take an example. So example is like there is a source code that is read A, read B, then you are checking for if condition whether A is greater than B or not. If A is greater than B, then print A is greater than B, else print B is greater than A, and end if. Okay, so this is the source code of checking the particular number is greater or not. Okay, so here there are two sets of code we are checking. Okay, so test cases as like if A equal to 5 and B equal to 2. Okay, so read A, read B, that is two statement. Then third statement is if condition, that is if A greater than B. Okay, if it is right, means we have value like A equal to 5 and B equal to 2. So obviously 5 is greater than 2. Okay, so it will perform the if condition print statement. Okay, so print A is greater than, okay, and it also ignore the else part. Okay, so for the particular set one, the number of statement executed are 5, that is read A, read B, then third is if condition, fourth is print statement, and fifth is end if statement. Okay, so here number of statement executed are 5 and the total number of statement in your source code is 7. Read A, read B, if A then print, else, print, and if. Okay, so total here 7 statement. Okay, so for calculating statement coverage, you have to define the number of statement executed, that is 5, divide by the number of statement in the source code, that is 7, on multiplication of 100. Okay, so the answer is 71%. Okay, so statement coverage of that particular example is 71%. Now let's take another test case, that is if A is 2 and B is 5. Okay, so that is the false condition, but that particular false condition is not supported in the statement coverage that we have already discussed. That is the drawback of the statement coverage. But let's understand the calculation of the false condition. Okay, so here if A equal to 2 and B equal to 5 means read statement is performed, then read B means first is read A, second is read B, then third is if condition. Now there is a false condition. Okay, so it will automatically redirect to the else part. So else, in which it will print B is greater than A. Okay, and last and if. Okay, so the only statement, that is print A is greater than B, is not performed in the false condition. Otherwise rest of the code is performed. So here the number of statement that is executed is 6. Total number of statement in the source code is 7. So the statement coverage equal to 6 divided by 7 into 100. So the answer should be 85.20. Okay, so this is how you can perform a statement coverage. Okay, so you can calculate statement coverage by using the formula. Okay, so this is all about the statement coverage technique. Now the second technique is about branch or decision coverage. Okay, so branch coverage is also known as decision coverage or all edges coverage. Okay, so it covers both the true as well as false condition. Okay, so it covers both the true and false condition, unlikely the statement coverage. And a branch is the outcome of a decision. So branch coverage simply measure which decision outcome have been tested. Okay, and this sounds great because it takes a more in-depth view. Okay, so you are checking for each and every condition. Okay, true condition as well as false condition. Okay, so this sounds great because it takes more in-depth view of your source code than a simple statement coverage. Okay, in simple statement coverage, you are just checking for the true condition, but here in branch and decision, you are checking for each and every branches. Okay, so the formula to calculate the decision coverage is like decision coverage equal to number of decision outcome that is executed divide by the total number of decision outcome multiplied by 100. Okay, so let's take an example of another example like read x, read y. Then you are checking for if condition x is greater than y. If it is right, then print x is greater than y, and last is and if. Here just only if condition is. Okay, so to get 100% statement coverage, only one test case is sufficient for this particular pseudocode. Okay, but test case one is like x equal to 10, y equal to 5. Okay, so you can perform easily a statement coverage. Okay, but however, this test case won't give you 100% decision coverage. Okay, as there is no false condition of if statement is exercised. Okay, so in order to achieve 100% decision coverage, we need to exercise the false condition of the if statement, which will be covered when x is less than y. Okay, so the final test set for 100% decision coverage is test case 1, that is x equal to 10 and y equal to 5, and test case 2, that is x equal to 2 and y equal to 10. Okay, so if you are checking for true as well as false condition, then you can easily calculate the decision coverage. Okay, so this is all about the branch or decision coverage. Now the third technique is path coverage. Okay, so the basic path method enables the test case designer to derive a logic. Okay, so what particular logic is performing during the software product? Okay, so what particular logic is performed in your software product that is calculated in a path coverage. Okay, so complexity measure of procedural design and use this measure as a guide of defining a basic set of execution path. Okay, so how many number of paths are being executed in your software and what particular time it took. Okay, so you are measuring for all the paths in your software product. Okay, so test cases derived to exercise the basic sets that are guaranteed to execute every statement in the program at least one time during the testing. Okay, and all possible controls part taken, including all the loops taken, 0, 1s and multiple item in techniques. Then the test case are prepared based on the logical complexity that is measured of the procedure design. Okay, and flow graph, cyclometric complexity and graph metrics are used to arrive as a basic path. Okay, so you can calculate path coverage by using a flow graph, cyclometric complexity and a graph metric. Okay, so let's take an example. There is a if condition, that is if a, then there is a function f1, then f2 function, then if a again, then f3 and f4 function. Okay, so here you can see that there is a path is given. Okay, so here path is given starting from a, then f1, f2, a, f3 and f4. Okay, so now here you can see that paths are given. Okay, so if a is true, then path is like if a, then f1 will perform, then f2 will perform. Then again, if a is again true, then f3 is performed and f4. So paths are like a, f1, f2, a, f3 and f4. Okay, now let's take an example like if condition is false at the first time. Okay, so a is performed, then f1 is not performed because that particular if condition is wrong. Okay, so it will not go in the subpart. Okay, so if is performed, that means a, then it redirect to the f2. So a, f2, a, f3 and f4. Similarly, here let's take another test case is like f3 is not performed, means the second if condition is wrong. Okay, so path is like a, f1, f2, a and f. Okay, now let's take another test case is like both the if condition are false. That means you are performing a, f2, again a and f. That means you are checking for if condition, it fails, means you are performing f2 function. Again you are checking for if condition, it fails, you are performing f4 function. Okay, so here problem means only two are feasible, a equal to true and a equal to false. So this is the example of path coverage. Okay, so all the paths are measured here. Okay, so in path coverage, all the possible paths are covered for the testing. Okay, so all paths are testing for the particular checking of a software product. Okay, so this is all about the path coverage. So that's all for the today's lecture. In today's lecture, we have learned about a white box testing. Okay, and in which we have also learned about various three techniques, that is statement coverage, then branch or decision coverage and a path coverage. So that's all for the today's lecture. Thank you.